Okay, let's prove the next theorem. It says if a and b are integers, not both 0, then a positive integer d is the greatest common divisor of a and b if and only if first d is a divisor of a and b, and if c is an integer which is a common divisor of a and b, then c is also a divisor of d. The statement contains if and only if, which means we have to prove two proofs actually. One is this direction, right, and the other one is the other way. Okay, let's prove the first one. We want to prove that the greatest common divisor of a and b has these two properties, that 1 and 2. So let's assume the first one, d is the greatest common divisor of a and b, like that. Then by the definition of common divisor, we know that d is a divisor of a and b. It should be. So the first part is clear by that. And by the theorem 17, we know that d is a linear combination of a and b, of course for certain integer m and n. Then if c is a common divisor of a and b, then by theorem 2, c is a divisor of ma plus nb, the linear combination of a and b, and that for certain m and n it should be d. So by that, c must be a divisor of a d. So we proved one direction. Let's assume that two conditions. So d is a common divisor of a and b, and if we found another common divisor of a and b, then c is also divisor of d. Then d should be the greatest common divisor of a and b. So let's assume the condition 1 and 2. From property 1, we know that d is a common divisor of a and b. That's clear. So all we need is d is the greatest common divisor, right? The largest one among them. Then from property 2, we know that if c is a common divisor of a and b, then c is a divisor of d. Therefore, d can be written by c times k for some integer k, which means c is actually d over k. That means it's less than equal to d. So this means if you choose any common divisor of a and b, it should be less than equal to d. So by that, d must be the largest among these common divisors of a and b. By that, you can claim that we have d is the greatest common divisor of a and b. That's the end of the proof.